I like to think of myself as a nice guy, a good boy, if you will. When I get revenge on somebody, I like to do things that are little nitpicks. Maybe I add an extra creamer, an extra sweeten load to your coffee. You're getting 3 today instead of 2. I make your day a little worse, but not too bad. Now, other people, they get revenge in a much different way. Some people like to get revenge by dropping multiple 0 days in Windows Defender. Windows 0 Day appears on GitHub, hackers run funnyapp.exe and gain system privileges, and then literally a couple hours ago, disgruntled hacker drops a second 0 day Windows Defender exploit just hours after Microsoft patches the first one. The person in question today is Nightmare Eclipse. Now, you know this is going to be a serious issue, a real hacker when they have an anime profile picture. I have yet to run into a hacker that has an anime profile picture that isn't really good at finding 0 days. It all started with this very vague blog post. First post, I never wanted to do this. I never wanted to reopen a blog and new GitHub account to drop code, but somebody violated our agreement and left me homeless with nothing. They knew this will happen and they stabbed me in the back anyways. This is their decision, not mine, on 26 March. And then a couple of days later, I was not bluffing Microsoft and I'll do it again, and they just drop a link to their GitHub. And unlike previous times, I'm not explaining how this works. Y'all geniuses can figure it out. And huge thanks to MSRC leadership to making this possible. MSRC, by the way, is the Microsoft Security Response Center. This is the organization at Microsoft that when big things go wrong security-wise at Microsoft, they have to deal with it. But also, MSRC runs the Microsoft Bug Bounty program. If you weren't aware, Microsoft runs a very thorough bug bounty program where you can get paid for a variety of vulnerabilities and a variety of Microsoft products. For example, if you have a vulnerability that is allowing a person to escape from a Hyper-V, the hypervisor, and you can escape from a guest in the hypervisor out to the hypervisor itself, they will pay you $250,000. I myself could, make use of $250,000. If you know a guy with an exploit he's not using, send it my way. But that being said, this person allegedly was trying to participate in the bug bounty process, and something, I guess MSRC didn't like their bug enough and ultimately didn't pay them. And so Nightmare Eclipse, Chaotic Eclipse, whatever, did release a POC. At the time of its release, was able to escalate a person from a regular user to system, and get this, it didn't just exploit Windows, it didn't have some crazy RCE and like the kernel, it exploited Defender, which is literally the antivirus platform that is supposed to stop you from getting hacked. Which is confusing because if you go to the MSRC site and you go to the cloud programs, they do have a Microsoft Defender program. Now, it doesn't seem like it pays a lot of money. Like, I think the RCE, or escalation of privilege, for a critical is $12,000, which seems a little low for me given the nature of how bad it would be to use Defender to escalate, but that's a different story for a different day. Let me be very clear. I don't think Defender is a bad piece of software. I think Defender is a very good antivirus. I think it's one of the best antivirus solutions out there. It's just really funny to me that the actual attack vector for both of these exploits, mind you, is Defender. Literally, the antivirus, the way that it handles doing antivirus, is what allowed Nightmare Eclipse to get the access that he got. Now, in these exploits, there's a lot of code, a lot of boilerplate, a lot of structs. Anything Windows related code-wise gets very big because of the way that the functions all work. The nature of this vulnerability is a time of check, time of use bug. The easiest way that I can describe a time of check, time of use is imagine you're going through a security turnstile at a concert, right? Well, the concert venue really doesn't like purple hats. Purple hats, you can't have them at a concert venue. I hate purple hats. So you go in and you're wearing a red hat. You walk into the security venue and they say, hey, you're wearing a purple hat, and they look at you and you say, no, I'm not wearing a purple hat. You're wearing a red hat. Okay, so you walk through the security turnstile, the security is no longer looking at you, and from your pocket, you pull out a can of purple paint and you spray your hat and you keep moving. Time of check, time of use is the time of validation of a function is different than the time that you use it. The control still remains with the user, and because of that, they're able to use that gap in check in use to do something malicious. And this exact vulnerability exists in Defender. So this is generally how Bluehammer works, right? And again, I'm gonna kind of miss out on a lot of the details because it's much more complicated than this. So this is generally how it goes, okay? So again, first of all, this is an escalation of privilege, meaning the attacker is already on the box, right? You have some local account that you want to escalate up to system, and you use Bluehammer to do this. So we have Defender here, and Defender is periodically reaching out to Microsoft and looking for updates, right? It's like, hey, do you have any more signatures for me? Do you have any new code, whatever? And it comes back as a .vdm file. The time of check, time of use vulnerability occurs in the downloading and the use of this VDM file. So when Defender goes to open this VDM file, the attacker is able to use a fake cloud file that basically blocks Defender from doing its update. It basically says, hey, this cloud file has not populated yet, so you can't do what you're about to do. In that window, the attacker removes the .vdm file and replaces it with a symlink that points back to the SAM file or the SAM hive. If you're not aware of what the SAM hive is, this is like your etc shadow equivalent in Windows, right? This contains all of the hashes, all the credentials for the local accounts on the box. And so when the cloud file then repopulates or is present, which is controlled by the attacker, Defender will go through and retroactively create a snapshot of the image before the update. It'll create a snapshot of the computer before the update, which, because Defender runs as system, it's able to make a snapshot of the VDM file, which is now a symlink to the SAM file. So in this new snapshot image of the computer, it's called a VSS file. This VSS file contains the SAM hive. And then from there, using the SAM hive, the attacker can do what's called a pass the hash, which basically uses NTLM authentication to pass around the password hash, use that to log in as admin, and then use that token to escalate the system. Crazy. So that was Bluehammer, and then there's Red Sun, which in the previous one, Bluehammer, they didn't give like a write-up. They kind of just said, like, y'all figure it out. I'm too smart, you're too dumb. Red Sun, they actually kind of wrote what happened. So normally I would just drop POC and let people figure it out, but for this one I can't. It's way too funny. When Defender realizes that a malicious file has a cloud tag, for whatever reason, the antivirus that's supposed to protect writes it back to its original location. The POC abuses this behavior to overwrite system files and gain admin privileges. I perused through the code a little bit, and again, this like came out a couple hours ago, like almost a day. So I think the way that it works is this. Now, real quick, before we talk about the Red Sun vulnerability, let's talk about today's video sponsor. Every day, it's more and more likely that your organization might get hacked. You gotta be prepared, and that's why today's video is sponsored by ThreatLocker. ThreatLocker is a zero-trust platform that allows your organization to stop hackers if they get in. With deny by default policies, your organization controls what happens when a compromise occurs. ThreatLocker's device dashboard allows you to have visibility of all the devices in your organization. When they join your organization, they go through an application control learning period where ThreatLocker learns exactly what is required for your device to run. After that control learning period is over, it will deny the rest by default, giving you confidence that untrusted applications aren't running. So that when Frank from engineering inevitably runs, definitely not malware.ps1, ThreatLocker blocks it before it even runs. And if they really need to run it, they can put a little message in here where your SOC can respond to it as soon as they see it. And with ThreatLocker's new zero trust network access, you can push network rules down to the device where every connection is intentional and required by the baseline that ThreatLocker collects. All traffic is blocked by default unless it matches your rules, where you get to control which users can connect, which devices are approved, and which resources are accessible. Guys, you know the rule. The best way to go help the channel out is to go interact with the sponsor, go give ThreatLocker a shot, and next time zero trust comes up at your company, why don't you mention ThreatLocker? Thank you for sponsoring the video, ThreatLocker. Let's get back to it. So Red Hammer is kind of funny, according to the POC author, if what they're saying is correct, right? So Red Hammer basically works supposedly by, you have the attacker, and the attacker's on the computer, and you have Defender, and basically what they're doing is they write a file to disk that has malicious data. Again, it has that EICAR string that triggers the AV to look at it and go, oh, we probably should deal with this file. Now, again, their claim is because this file also has a cloud tag, meaning that it came from the cloud or like it lives in the cloud. I'm not sure what this cloud tag does, but because it is tagged with cloud tag, instead of removing the file, it'll write it back to where it came from before it quarantines it. Now remember, Defender runs as system. So all of the reads and the writes are being done with system level privileges. But the time of check, time of use happens here where the time of check, they make sure that the EICAR string is occurring and that it lives at this location. But by using that same locking strategy where they can make Defender block for a little bit with sync root thing, the attacker replaces the location of the file using a temp mount point, right, to point back to system32. All the while, it also changes the contents of the file to contain a program, causing Defender to write the program to system32 and installing it as a service, right? So it literally takes the file that's attacker controlled and copies it wherever the attacker wants because of this cloud tag thing. And again, I'm not sure how this works or why this works, but that's what the attacker is claiming, which is, if true, I haven't tested it yet. I don't trust this exploit enough to test it locally. If true, completely bonkers. And that's why, ladies and germs, you should never mess with a person who has an anime profile picture. Now, I know what you're thinking. Would Rust have fixed this? No, not at all. So Rust is a memory safe language, right? Time of check, time of use race conditions are not a memory safety issue. They're more of like a logic or implementation issue. And here literally is an example in Rust of a time of check, time of use issue, where, for example, you have an insecure file access. And so what the code does is it checks to see if the file exists and is okay. And if it is okay, then it reads the data to a string. The issue here is that if this file, this program runs as a different privilege, for example, the way that this access works, the attacker, in between these two calls, there's a race window where the attacker can change the contents of the file name because it's not being opened here. They're just checking for the file to exist, right? Then they open and read in the same function. So because there is no lock occurring here, the attacker could replace this file with like a symlink to Etsy password or Etsy shadow or like some privileged file in that window. And so that's kind of the issue with time of check, time of use, right? Patterns in code that to the average person look fairly benign, like there's no like malicious code or like bad functions. The way this works under the hood prevents a really interesting race window for attackers. Anyway, guys, that's it for now. Thanks for watching. I appreciate it. If you liked this video, go check out this other video about an attack that was pretty cool and kind of just like this one. We'll see you there.